So I was tinkering around with ChatGPT, so I finally decided to make an account and try out ChatGPT because everyone is talking about it. I didn't want to check it out because I thought I was late, but the more I think about it, the late I become, the more late I become. So I finally decided to try it. So let's. So I asked ChatGPT some basic questions, and then I asked a difficult DSA problem, which we are going to solve as well. But I was really shocked by how fast this actually returned me the answer. But this answer is pretty bad, in my opinion. We can definitely get some things out of this, but see, the code this guy has generated is ending at something that will not even compile in Python. So we're gonna ask this question again. Let's see what happens one more time. So because I don't want to remove that answer, so I've asked the same question again, and now it's giving me a different answer, which is weird. And we cannot use a greedy approach. I think this is wrong. This question shouldn't be this easy that we can solve it by greedy approach, I guess. I'm not sure because I haven't solved it yet. I'm asking ChatGPT because I haven't solved it yet. That's the reason. Let's ask this again. Manufacturing unit. Let's ask this question again. One more time. Let's make a test case to test this guy's code with it. Yeah, let's actually make a test case. That's the worst part. This is giving me the pseudocode. Is this pseudocode? This looks like Python code to me. This looks wrong to me again. Okay, let's see what the question is. Can it print a diff algorithm for me? Can you run C++ code? I don't want to install on my Mac. But there is no good testing environment. I don't even know. Diagrams by Miro. What's this? I want a fully walking environment like code spaces. Let's open this, I guess. Should I open this? Let's give this. I can regenerate response. Okay. Never mind. That's the worst code I've ever seen. Never mind, let it do its thing. Let's call it ChatGPT. That's not what I want. That's definitely what I don't want. So if I have like a file, what I really want is that expected.txt should have my expected output, and I wanna have a test.py file in which I run this test. This will actually test my answer against this input and check if output matches the expected output. How did I write output dot? Okay, there's nothing in this. There's nothing in the input. Expected is 1. So I want to test that. So to run Python file, I can do Python answer.py and then insert input.txt into it, and then output inside output.txt. No such file or directory. You can use the same command inside of this folder. Fuck. And now if I look at out.txt, this should contain 1, and I want to do and def expected.txt with output.txt. Does the diff work? Can we use get here? Let's use get diff. I guess this kind of works. So what I want is this the sample input. So what this is saying is that there is no if I do this should work as expected, and this should return nothing. Okay, I can use this. How do I remove lines from this shit? I don't even understand how the fuck is this an input. This is the sample output. Output. And I want to create multiple test cases, but since I only have one for now, so the explanation is before year 1, product 1, product 2, 3, so 3 products. Before year 4, 1, 3 on assembly 4. Zero, okay. But for 4th one, we still have 3, but here it says only 2. How the fuck do we have 3 here then? good stuff. Okay, let's first discuss the question, I guess. So the question is, there is a manufacturing unit having some set of assembly lines. Let's make some assembly lines. Alright, and there are m assembly lines, so m of these, and there are n products, n of these, right? So each product can be manufactured on one or more, so basically the relationship is for product to assembly lines, it is 1 to many, I guess. These are given k combinations of the form. So you're given k combinations of the form x comma y, and x can be manufactured on y basically. Okay. So I guess this is n colon x n because one assembly line can actually get 2 or more products as well on itself. So each assembly line has a capacity known as capacity. So let's keep it C of I. So each one has a different capacity, and every year one particular assembly line reduces by number P. So a lot of fucking variables. So every year one particular assembly line's capacity, okay, one of them reduces by P. So one of them, okay, 1 minus P every fucking year, and the data is known for Z years. I don't know, this question is going places. For each year before the reduction takes place, you need to predict the maximum number of products that can be produced. Okay, now which line is going to get reduced by P? I don't even know. So we have N, M and K, so that's how we're gonna take the input. Let's write that, and the problem is I'm gonna write in C++, and this thing is gonna write in, this thing means ChatGPT is gonna write in Python, I guess. Let's do a.cpp. So what I'm gonna do is so we don't have test cases. That's a good point. So we have int n, m and k. Not a good point to take it as int, but never mind, we're gonna see the constraints later. Next, k lines contain 2 integers x and y. This code looks like plagiarized, so everyone will take variables like this, so we should add our own things into it. Never mind. There is an array of size m consisting, okay, so we're gonna take a vector, and for now let's take long, I guess. It's never bad to take long. is gonna be capacity. It's gonna be of size m, 0, and we're gonna input it. Now what? Integer z. Okay, they have given the details about which assembly line is getting reduced by capacity P. Okay, z lines. So I'm gonna take a vector of pair of long, which is gonna hurt. Should I take it as input or just take like consider it as test cases? Let's just take it as input and think later. If we don't have to, it's fine. So this is gonna be R and P. So this is showing the assembly line. Let's keep it R as they want us. So I cannot initialize it by 0. Let's just keep it like that. So I'm gonna take this for loop, copy paste it here. I want to write a way in which, like, at least AI is not good enough to solve this problem, but it should be good enough to take the input at least, right? But it's fine. RP. I guess that's the way to take the input. I don't even know if that works or not. I haven't taken input like that in like forever. So this should be RP of I, my bad. And I don't know about, like, I know that cout is joinable like that. Scene should be joinable like that, but I haven't used it ever. So this should be fine. And we're gonna print Z lines. So we're gonna use the loop again. As the number of products that can be produced. Let's see out 1. Let's see if this code fucking works first. I'm gonna use this template and I'm gonna use G++. A.cpp, I'm gonna output it in A and I'm gonna run it with the input and place it in output and I'm gonna diff it. No such file or directory. Okay, we haven't saved this file. For an array subscript. Too few arguments. Okay, my bad. That is what I meant. Oh, this actually worked. So let's create a single line to run it and test it, so that we don't have to do it again and again. So I want to git diff, in fact, git diff output.txt with my expected.txt. this. Oh shit, this doesn't tell me anything. Why isn't this school like VS Code? -1 +1. What the fuck? Okay, never mind. So the output should be 1 1. So at least we now know that Z is 2 in the given input. I didn't even know that Z is 2. So NNMK and then M size for CI capacity. How is the capacity? Okay, this is the K line, sorry. K lines for X and Y. So this is fucking wrong. So we have to see, we just made a mistake just while taking the input. Fucking input. How long this is gonna take? We should use a data structure probably, but we are not using. So this is gonna denote XY. Should use a class, but we're not gonna use it. I don't know why. We can think about beautifying the code later. Finally, we got some autocomplete. What was swap? There was a swap. Wow. We don't need this. So the better thing should have been taking a matrix or taking like what do you call it, adjacency list for X and Y, because X can have multiple Y's and then Y can have multiple X, so we can think of maybe XY or something like that. So this is the worst data structure that we could have used, so we are gonna remove this. So let it be. Segmentation fault. Fucking segmentation fault. Okay, let's not cry. Access up till n. I can't even take fucking input. My bad. We could push back, or we could actually declare the size of the vector, and that looks good to me. The output is 3 1s. And expected is, how the fuck did expected change? My bad. I didn't type it in expected. I maybe typed it in output.txt. Okay, it's getting pretty late actually for all of this shit. I should probably continue tomorrow. There is a new line character. Wow, there's a space character here as well. Moving the empty or invisible characters is so fun. I'm gonna save this file at least. Wait, if according to my input the X is 3, then how is this printing out 3? 7 fucking lines. 7 fucking lines. I guess Z is 7 and our basically input taking is wrong. That means So this is wrong. Got it. This should produce the right output. Yep. 7 positions and a fucking invalid character. So how do I prevent it from printing an extra new line character? I guess I cannot. Then let's just add it in exp as well. How do I fucking see the actual diff, bro? This is not a diff. Let's see. Let's remove the get. This is just showing me the line numbers and not showing actually what has changed. See, this is showing me something, but it's still bad. I want to see a good diff. I want to see a good diff. Just show me a good fucking diff. I guess there is no better way than the diff. So the cool part is that we are actually getting 7 outputs at least. So the input taking part should be fine. And now we have to print out the answer. So I'm just gonna print out the stats for now. I'm gonna print out the capacity of each of the elements, right? Let's modify our query to actually see the output. So I want to see, I should make a print function, but never mind. For auto x in C, see out in x, see out in handle. I should use /n for faster response time, but never mind. So this is the capacity of each and every assembly line. So apparently we have 4 assembly lines right here, which is given by the m amount. So the m is 4 here, right? Let's see those assembly lines fall. So if we're gonna reduce the C of C of what? RP of Z dot first RP of I, sorry. So the I is playing the role for Z here. We have second. So yeah, that's the thing that's happening. This guy is not happy. Why is this guy not happy? Now this guy is happy. So year 1, before year 1, okay. So we're gonna reduce this after we. So at year 1 we have all of these stuff, and before year 4 reduction we have 1 on assembly line 2. How the fuck assembly line 2 is wasted, bro? Assembly line 2 is wasted, bro. Okay, so I guess they are indexed by 1, so I have to either reduce 1 or add 1, so whichever is actually easier. So I'm just gonna use this. So this is gonna reduce the R. Capacity of 3 reduces by 4. I don't see that here. This is actually not getting reduced by 4. Bruh, it's getting reduced by 2. How the fuck can I make that mistake? Bruh, what the fuck is happening? Weird stuff. Oh, my bad. Okay, so the capacitor reduced by 4 to 1. Capacity of 2 reduced by 1. Yes, sir. 1 reduced by 3. Yes, sir. 4 reduced by 2. That's not happening. Okay, that's happening. 2 reduced by 1. Okay. 4 reduced by 1. Okay. 3 reduced by 1. It goes to 0. So we have this at least for now. Let's think of the other part of the problem later, maybe. So just have the capacities. I have a lot of work to do. Let's get to the difficult part at least in this video, and then we'll leave it. So the difficult part is so each product takes 1 capacity, I guess. Yeah, 1 capacity, thank God. So it's basically the number of products it can make, right? Doesn't matter which product, it can just make this many products, I guess. Yep. So the X to Y mapping, that's gonna be difficult. Do I want all the products for this assembly line, or do I want all the assembly lines for this product? I would prefer all the products for this assembly line, right? And that's gonna have a lot of time complexity, but it's gonna be better, I guess. Let's think this through. So do I want I guess the first one. So the way I'm gonna use this is I'm gonna create a map, unordered map. So let's map it to a vector. You can use anything though. Products for line and so for line number this I'm gonna use how many products capacity, how many assembly lines am right? China. C+1, I guess. For every product in products for line, right? Can't I just add the number of products if the prods for line c plus 1 is greater than 1, dot size of course is greater than 1, and the capacity is greater than 1, so c of c is greater than 0, and the number of products I can make is greater than 0 of course. And then I can just add answer or this year production this year plus equals to c of c, I guess. Some label long production this year 0, and I'm gonna see how production this year, and that's it. So this is definitely wrong. So this guy thinks the production is going to be 8, but the expected is 3. How does that happen? So पराठा चाहिए. Can't we make more products like same of the same type? So like capacity is 3253. So we can only make 3 products. How the fuck? Oh, since we only have 3 products, 1, 2, 3, 4. One can be made on 1. One can be made on 2. 2 can be made on 2. Oh, since we are making 1 on this guy, we cannot make 1 on this guy. Oh, that's the shit. Okay. Plus, it's not about the capacity. It's like only 1 product can be made of type 1. We cannot create multiple products. So I guess my decision of taking this was wrong. It should have been this, since each product can be only made once. Each product can only be made once in 1 year. If one line made that product, we can remove that from other lines capabilities, or we can't make it on other lines as well. Basically this is the one thing that came out I didn't quite get from just reading the question. And another thing that came out is 1 x can have multiple y's, 1 y can have multiple x's, and it's all a bunch of mess. It's all a mess. It's all a big mess. Let's just check that if this is still right. This 8 is fucking right or not. So each fucking assembly line has something except 3. So we're not gonna count this. We're gonna count 3 plus 2, that is 5 plus 3 is 8. So that calculation is correct, I guess. And we can print out the C as well. So what we're gonna do is we can print out C of C. So 3 to 1 3, so 8, still 8, 3 1 3 7. This should be fine. So either we can go with this approach, or we can just try and optimize for this approach. To optimize for this, or going ahead with this, what we can do is we can create a vector of already made products. So this is gonna be vector products made. So and since so the capacity doesn't really mean anything. Assembly line has a limit on the number of products it can produce. Then what is the use of capacity if we can only make one product? Oh, so something like this is possible. So 2 line 2 has a capacity of 2. So and 1 and 2 both can be made on it. So we make both. That is the case that we missed. I guess this is the way. I'm not sure. It's all about like this thing can make X products, but it should have products it can make. And if I can suck at this question clearly. Because it can be greedy. No, why not? Is it greedy? Can we just take what products we can, or should we optimize? Of course we should optimize. Why? Because consider a situation like this. So line number 2, let's say, can make 1 and 2, right? So, and line number 3 can only make 2 or 1, let's say. And if we give 1 to line 2, then we can't make 2. So each year the number of products that we can make is at max the number of different products. That is the number of different x's. And how do we know how many number of x's are there? That is written by n, right? So let's just, instead of doing this shit, let's just add in the answer plus equals n, then I just leave this. Okay, not this. But this. So we assume that we can make n products, and then we can subtract some of the shit that we can't make. So deciding the first best bet, it's difficult. This question is fucking difficult. Okay, and this is what the AI suggests, which is completely wrong in my opinion. Let's see if this actually works. This guy says we can use a greedy approach, which is completely wrong. Oh, choose the one with the maximum capacity. Interesting. Choose the one with the maximum capacity is not correct. As we can see here, let's say this guy can make 2. You can then reduce the capacity of that assembly line by 1. As 1 unit of the product has been manufactured, we keep the track of total number of products produced printed out at the end. This is wrong, my friend. The reason it's wrong is because we don't choose the one with the maximum capacity, because it can betray us. So let's say this guy has a capacity of 2 and this guy has a capacity of 1. No. So for making, okay, it kind of makes sense. It kind of ruined my test case. Let's think of another test case. because now we can actually make 2 out of it. Let's make it to be 3 as well, right? And let's say line 1. Let's take a line 1. Line 1 can take 3 and also capacity of 1, right? So if we give 1 to line 2 and then reduce the capacity, reducing the capacity, will it fucking work? Will this fucking work? You and I guess this will work. This greedy approach is kind of working, in my opinion. Let's not remove this. What is the other approach this guy thought of? You and this is total bullshit, I guess. Let's see this one. Max flow in a bipartite graph. Looks cool, but can be absolute bullshit. Of course it is. By the code, I guess. Let's copy the code. So this guy says to solve the problem we can represent the semblance and products as a bipartite graph. Why can it be a bipartite graph? Each product will be connected to the assembly lines that it can be manufactured on. You can then use the max flow algorithm to find the maximum number of products that can be produced. Graph with n plus m plus 2 nodes, where n is the number of products, m is the number of assembly lines, and additional 2 nodes represents the source and the sink. You will connect the source to all the products. Products don't have capacity, bro. And connect all the assembly lines to this sink with the capacity equal to the respective capacity. We will also add edges between the products. Then for each year we will reduce the capacity of this specific assembly line by P and on the max flow algorithm to find the maximum number of products, and the output for each year will be the max flow of the graph. What the fuck? Bro, just wait. I don't even know what is the max flow algorithm. I guess that would be good to know. Okay. Why would it be a bipartite graph? And what is exactly a bipartite graph? So bipartite graph is we can color the graph into 2. So basically any node with a red color will not touch any node with red color. It will only be a green color touching with a red color. So that means I don't know what that means. This is some bullshit. Or maybe this is the correct way. But why would you end the code like that, bro? No, there's no slowing down. Oh, it's trying the object oriented approach. Ahaha. I like it. But this is wrong. Why would an assembly line have reductions? But this is just taking the input. How is it gonna solve? How is it gonna solve, bro? Okay. Bullshit. Again. I don't want to delete that response. I just want to keep it. It's still, it's again using the source sync approach. That is for basically bipartite graph and max flow algorithm. At least this time it's producing full code and not just. Oh fuck. Why would you not go beyond that? Is there a limit? Or what the fuck? Why would you stop at that point? Copy code. Let's code. Oh shit. How the fuck can you produce such bad? How can this even run? Will this fucking run? No such file. I'm gonna save it. See? This is bullshit. So not even calling any function plus this is producing wrong code. Never mind. This thing is not good. And it's 3:19 a.m. Fuck me.